Hi everyone, I am Valentina Sanmiguel, a Master of Sustainable Energy and Environmental Management student in the School of Public Policy, and I am going to present the economics of biomass cogeneration plants in Georgia. The objective of this study is to assess the economic performance of 4 biomass cogeneration plants in the state of Georgia using the levelized cost of electricity, or the LCOE. I am going to start with some definitions. So biomass is organic material that comes from plants and is a renewable source of energy. It contains energy stored from the sun that is absorbed by plants through photosynthesis, a process that transforms radiant energy into chemical energy in the form of glucose. Biomass can be burned to release the chemical energy as heat directly or converted to biogas or biofuels that can later be burned for energy. The heat release can create steam or run a turbine in order to generate electricity. Some examples of biomass include wood and wood waste, agricultural crops, food, and waste. In the picture here, we can see wood pellets that can be used to cogenerate. Cogeneration is also known as combined heat and power, or CHP, and involves the co-production of beneficial heat and electricity. CHP reduces emissions by displacing the consumption of fossil fuels that would otherwise have been used and can reduce electricity consumption from the grid. And the LCOE is a commonly used indicator to evaluate and compare the relative costs and electricity generations of different technologies, calculated by dividing the present value of plant cost by discounted lifetime of electricity generation, as we can see in the equation below. This means that we want to find the cost to generate 1 megawatt hour of electricity. Therefore, the lower the LCOE, the more cost effective. I first selected the biomass plants listed here. They are located in different counties across Georgia and have an installed capacity greater than 50 megawatts. Albany Green, the one that we see in the picture, is located in Albany, Georgia. In order to calculate the LCOE, I used the assumptions shown in this table. The discount rate and lifetime come from previous LCOE studies for 4 biomass plants in Virginia. The operating variables and the costs were the actual values for the plants in 2018 that I got from the S&P Energy database. The results are shown in this table. The LCOE for the biomass plants in Georgia range from $79 to $138 per megawatt hour. The results show that the levelized fuel cost is the most representative cost for the plants, followed by the capital investment, and the other O&M costs are not significant compared to the capital investment and the fuel cost. It is also important to note that the biomass cost is what makes the LCOE differ significantly between the plants. Lastly, the results are reasonable compared to another LCOE study for 4 biomass plants in Virginia that yielded LCOEs between $93 and $143 per megawatt hour. Thank you for your time, and please let me know if there are any questions.